Ladies and gentlemen, I already made a long video explaining every single question, all right? So what I'm gonna do is make a shorter video explaining like one of each type, and then you guys could, if you need help on the other ones, go back and watch the longer video. The answers themselves will be uploaded to Edmodo. They're also posted on the back wall if you wanna take a picture of them before leaving. So I do wanna go over this first one. The test is all gonna be multiple choice. That's to get you ready for the final. The final should be even easier because right here we have 5 different possible multiple choices or even more. The test is always A, B, C, or D, only 4 possible multiple choices. Now the first thing that's kind of confusing is the notation that this exam and the final exam have for end behavior is a little backwards than what we used. Notice the end behavior of the graph is f of x. They're talking about the y values first before the x's. But nevertheless, it still makes sense if you understand what you're reading. It's saying that the y values go where? Do they go up or down? Up. They go up as your x's go to positive infinity. As you look at it, in which direction? To the left or to the right? To the right. Okay, so the graph goes up as you look at it to the right. Does this graph go up as you look at it to the right? To the right, it goes up. To the right, it goes up. To the right, it goes up. So far, every one of those is possible. So let's continue reading. It says, and it goes back to the y's again. Your y's go up. You're thinking, wait a minute, we just said it. The y's go up. Yeah, again, the y's go up as the x's go to negative infinity. What does that mean? As you look where? As x's go to negative infinity, that's to the left. Right? X's are left and right. Positive infinity, negative infinity. F of x's, the y's are up and down, positive infinity, negative infinity, right? So again, as the y values go up, the y values go up as your x's go to the right. The y values go up as your x's go to the left, right? So that means to the left it goes up, to the right it goes up. This is the correct answer so far. Is this guy an even degree polynomial? Yes. Both end behaviors are up here. If you have 2 arrows going up, that's the number 2 is even. If you only have 1 arrow up there and 1 arrow down here, then it's odd. These guys are odd. This guy's even. If you had both of them opening down, it would still be even, right? Okay, so far, option A belongs to this first one. The third detail, the function has 4 real zeros. Does this have 4 real zeros? Yes, it does. There's 1 real zero, 2 real zeros, 3 real zeros, 4. Remember, real zeros, real answers, real roots, real x-intercepts all mean the same thing. They're all solutions. So that's how we do number 1. Do you think we need to explain 2 and 3, or are we good? By the way, there's a typo. It says right here, number 1 and number 2 above. It should be 1, 2, and 3 above. Sorry about that. Should we move on? Yes. If you need help, watch the other video. I explain every question on the other video. So the next thing that we're faced with on this test is sum and difference of 2 cubes. So let's look at number 4. It looks like a sum of 2 cubes. The question is, do we know the formula? Formula should be a cubed plus b cubed equals a binomial times a trinomial. The binomial will be exactly the same without the cubes. So my binomial is going to be a plus b. My trinomial is always going to start with a squared. And then if your binomial had a plus sign in the middle, the trinomial is going to have a minus sign in the middle. And of course the middle term is a and b multiplied together. And the last term is plus b squared. So we have to memorize that. The difference of 2 cubes is the same thing, but instead of a plus right here, it'd be a minus, and instead of a minus right here, it'd be a plus. So, can we look at number 4 and rewrite it as something cubed plus something cubed? In other words, what times itself 3 times will give us this entire 64x cubed? 4x times 4x times 4x really will give us 64x to the third. How about what times itself 3 times will give us 125y cubed? 5y. So this part right here is not really part of the formula, but it's essential to identify your A value, which is 4x, and your B value, which is 5y. So now that we identified A and B, now we could actually jump right into our binomial times the trinomial. The binomial will be the same exact thing without what? Without the parentheses and without the cubes, right? So what's the binomial going to be? 4x plus 5y. Whoops, had to write small right there. It's kind of ugly. Now the trinomial, I always recommend using parentheses. Unless you have a single number or a single variable, then you don't really need parentheses. But a squared, what is a? 4x, okay? And then minus b squared, or no, a times b, I'm sorry. B squared's at the very end. What is a again? That's a 4x. And the b is 5y. And at the very end we have b squared. So that's a 5y squared. Sorry, it's ridiculously small. Let me zoom in. So on the trinomial, when you simplify, 4x squared, not 4x squared, 4x in parentheses squared, that's 4x times 4x, 16x squared. And then over here we have a negative 4 times 5, that's a negative 20. X times y, that's xy. At the very end, what do we have? Plus 25y squared. And the binomial just stays the same. So there's my factored form of that sum of two cubes expression. So on the multiple choice tomorrow, I'm going to say which one of the following options is a factor. Maybe both of them are there, maybe none of them are there. What's the answer here on number 4? Only D, right? It would be A and D if this one was a plus, right? It would start with a plus, but it's not, it's a minus, so that's not a factor. So, do you guys understand sum of two cubes? Same thing with number 5. You would apply the difference of two cubes on that one. I'm going to skip 5. Number 6 could be done 2 different ways, actually 3 different ways. What do they want you to do? They want you to divide that cubic binomial by the linear binomial. So you could use long division. I wouldn't do that. You could use synthetic division. That's a good option. Or you could recognize that there's a difference of two cubes right here. If you recognize that there's a difference of two cubes right here, let's do this to identify A and B. What is your A value? In the first parenthesis, X. What's your B value in the second parenthesis? 4. Now notice this is a single X as the A value and a single number 4 as the B value. So in this case, I don't have to use parentheses. When I go binomial times a trinomial, I could just jump right in and say, okay, X minus 4. Now, right here goes the A squared, right? A squared. Wait, does everybody know what I'm doing? Or do I need to write the formula for you guys? Let me jot it down. So there's a formula up there in case you didn't know what I was doing here. I identified the A, the B. I plugged it right into my binomial. If it started with the minus sign, it's going to start with the minus sign. Just forget about the cubes. You have your first binomial. Then right here is your A squared. And what is X squared? It's X squared. That's why you don't really need parentheses. You can just jump right in and say X squared. Now the middle value, if it was a minus, is going to be a plus. So we put a plus. And in here I have A times B. You could just do this in your head. X times 4. What's X times 4? 4x. And at the very end, we have a B squared plus B squared. So I'm going to put plus 4 squared. But what is 4 squared? 16. So when it's a single X and a single number like 4, you don't have to use parentheses. If you want to, go for it. It might be a little safer, but you don't have to. But anyways, we factored it, right? Now, they didn't ask us to factor. They want us to divide. But this factored becomes this, and divided by this binomial is, you could write it like this, divided by, as a fraction, that binomial, which means you have the same binomial on top and bottom, which means you could cancel them out, and there's your answer. So using the formula, if you're comfortable with the formula, it's really easy. Let's say you're not too comfortable with the formula, then go ahead and do the division but with synthetic division. It's not bad with synthetic. With synthetic division, what belongs inside of the box?
4.
Positive 4, right? You think opposite only because if you were to set it equal to 0, you would solve by adding 4, and x would truly equal 4. That's why we're plugging in a 4. Now the coefficients for x to the third, the coefficient's 1. The coefficient, that coefficient for x squared is 0. The coefficient for x is also 0, and the constant for is negative 64. So synthetic division, as you go down, you add. 1 plus nothing is 1. As you go up, 4 times 1 is 4. As you go down, you combine. 0 plus 4 is 4. As you go up, you multiply. 4 times 4 is 16. As you go down, you combine. 0 plus 16 is 16. As you go up, you multiply. 4 times 16 is 64. The remainder is 0. So this guy right here is the answer. Those are the coefficients of your depressed polynomial. So the depressed polynomial would be 1x squared plus 4x plus 16. That's your answer. It's the same exact answer as up here. So I showed you both methods. You don't have to do both. Just whichever one you feel more comfortable with. If you're good with the difference of 2 cubes formula, go for it. If you really like synthetic division, go for it. Which one's faster? I don't know. They're both pretty much just as fast. The one that's definitely slower is long division. Don't do that, okay? Does anybody need this review of basic factoring? You pull out the GCF, and then you have to use that long process of A times C, and then think of the multiples of that answer that combine together to give you B. Anybody want to review that? No? Okay, so if you do want to see that, it's on the other video, right? Just making a short video to give you a little taste of everything here. If you could figure out those answers of the ones I haven't done, then maybe you don't even need to see the entire video. Right here, factor. What kind of factoring are we going to do? Could you pull out a GCF? Not from the whole thing. So what do? Group. Factor by grouping. So first make space between your first 2 and your second 2. Now, what could you pull out of that first group? An x. What would be left on the inside? Yep. What could you pull out of the second group? And what would be left on the inside? X minus y also. Luckily, we have the same common binomial here and here in the first group and the second group. So I'm going to pull out that common binomial. I'm going to have an x minus y out here. And I have some exaggerated parentheses. What's left? The x is left over, and the 3 is also left over. X plus 3. Final factored form, x minus y, x plus 3. And believe me when I tell you this, guys, I designed this test in multiple choice so it'll mirror the final. Okay? So not only is this practice test good for the test tomorrow, but it's also going to get you ready for the final exam. All right? These exact type of questions come out on the test tomorrow, and they come out on the final exam. So please study this like no other test. Study a lot. Let's go to the back side. Given a polynomial and one of its factors, should we do 9 or 10? You pick. If you understand one, you'll be able to do the other one on your own. And if not, you still have the video. 9 or 10? 10. All right, let's look at 10. They tell us that this is a factor of this polynomial. Now, if you take any value and divide it by a factor of it, you're going to have 0 as the remainder, correct? I mean, 4 is a factor of 12. If you divide 12 by 4, it works out beautifully. There's no remainder, nothing left over. So right here, they're telling you this is a factor of this. So if I were to divide them, I want to get a remainder of 0. Let me show that by doing synthetic division. What goes inside of the box?
1.
Negative 1. Again, because this is a binomial, right? If you were to set it equal to 0 and subtract 1, x would equal 1. That's why we're plugging in x would equal negative 1. That's why we're plugging in a negative 1. Make sense? Okay. What are the coefficient values? 1, 4, Close?
Negative 7.
-7?
Negative 10.
-10. Perfect. As you go down, you combine. 1 plus nothing is 1. As you go up, you multiply. -1 times 1 is -1. As you go down, you combine. 4 and -1 is 3. As you go up, you multiply. -1 times 3 is -3. -7 plus -3 is -10. As you go up, -1 times -10 is +10. The remainder is 0. That doesn't surprise me because they told us that this guy's a factor. It better be 0, the remainder. If not, I did something wrong. Why did I do this in the first place? Because they want us to factor. They want us to find the other factors. And I'm really good at factoring quadratics, not cubic, right? If I could have done grouping, I would have factored by grouping. But there's no grouping to do here. So I did this to get a depressed polynomial. And that depressed polynomial will be x squared plus 3x minus 10. And I'm really good at factoring quadratic trinomials, especially when the a value is not 1, right? What times what is -10 that if I combine together is +3? +5 times -2. Come on, guys. Right? Okay, so there are your factors. If you wanted to, you could even write the original binomial that they gave you that they said was a factor. And this is your completely factored form, right? But what are they asking for? Which of these multiple choice answers are factors? D. And that's it, huh? Because x plus 5, if that were a plus, it would be C and D. But it's only D in this case. 9 is done the same exact way. What are you going to plug inside of the box?
3.
Yep, +3. All right. Down here, 11 or 12? I want to go with I'll go with 12. Now, they just want you to solve it. And in order for you to solve this, you got to think of the multiples of 20, plus or minus, over the multiples of your leading coefficient, which luckily is 1. So imagine this huge long list. How could you get 20? Could be 1. Could it be 2? Yes. Could it be 3? No. Could it be 4? Yes, because 4 times 5 is 20, which means 5 could also be it. 6 doesn't work. 7 doesn't work. 8, 9, 10. 11, 12, all the way to 20. And also all negatives. Isn't that ugly? Man, that list is too long. Now, tomorrow's test is multiple choice. The final exam is multiple choice. Would you plug in 20 or -20 based on those answers? Or 10 or -10 or 5 or -5? Do you see any of those answers on these multiple choices? Which ones do you see? -2 and also +2. So let's start by plugging in what? What's a good educated guess?
3 -2.
Yeah, I'd go with -2 because it pops up 3 times, right? Pops up on option B, on option C, option D. More likely it's going to be an answer. So let's plug in that -2 right in there. Let's put the coefficients. The coefficient of x to the third is 1. The coefficient of x squared, it's not even there, so you're going to put a 0. The coefficient of x is 6, and the constant is 20. As you go down, you add. 1 plus nothing is 1. As you go up, you multiply. -2 times 1 is -2. As you go down, you combine. 0 and -2 is -2. As you go up, you multiply. -2 times -2 is +4. As you go down, you combine. 6 plus 4 is 10. As you go up, you multiply. -2 times 10 is -20. As you go down, you combine. And as you could see, the remainder is 0. We found an answer. X equals -2. Yay! Now we need some other answers. So based on our multiple choice, we could try to test +2, but guess what? We already have 3 numbers down here as our coefficients of our depressed polynomial, which means we have a quadratic equation. And like I said, we're supposed to be professionals at factoring or solving quadratic equations. So let's write the quadratic equation from here. X squared minus 2x plus 10. Now, they don't want the factored form. They want the answers. So this is really an equation set equal to 0. If I could factor it, I'm going to split it and get my two answers from there. Could I factor it? What times what is 10 that if you add together is negative 2? It doesn't work. Unfortunately, it's not factorable. Does that mean I just stop? No, I could solve this thing. How though? With the quadratic formula. There's your quadratic formula. When you use the quadratic formula, please replace your B's, your A's, and your C's with parentheses. So our A value is 1, our B value is negative 2, and our C value is 10. So let's plug in our B value of negative 2 right there and right there. The A value of 1 down there and up here, and the C value of 10 right there. Let's work on the discriminant, the value inside the square root. So I do have negative 2 in parentheses squared. That's really a 4. Let's put a 4 right here on the side. And then what's 4 times 1 times 10? That's 40. So I really have 4 minus 40 inside the square root. 4 minus 40 is negative 36. So you're really doing the square root of negative 36. Let me rewrite everything. I have a positive 2 plus or minus the square root of negative 36, all divided by 2 times 1, which is 2. What is the square root of negative 36?
6i.
6i. This is really 6i. So let's rewrite it. 2 plus or minus 6i, all divided by 2. Now, whenever you have something plus something else or something minus something else, all divided by 2, you could take that division of 2 and split it to each of them, making 2 fractions. Right? So you could go 2 divided by 2, giving you a 1, and a 6 divided by 2, giving you a 3i. Or you could simply reduce everything by 2, and you get the 1 plus or minus 3i. So you really have 3 answers for this cubic equation. One answer is real, negative 2, and the other answer, or the other 2 answers are imaginary, 1 plus or minus 3i. So the answer is C, negative 2 and 1 plus or minus 3i. So you guys should be able to do this one the same exact way. If you need help on it, please watch my other videos. Down here, it's the most important one. 13, well, not the most important one. It's pretty basic, actually, if you think about it. They give you the answers, and they want the equation that gives you those answers. So let's do this whole process backwards. First, let's begin with saying x equals negative 3. Let's also begin with saying x equals negative 5i. Now, we did learn the complex conjugate theorem that says if they give you an answer that's imaginary or that's a complex number, then the complex conjugate is also an answer automatically. So what is also an answer automatically that's not shown here?
X equals 5i.
X equals positive 5i as well, right? So I probably should have written it down here. X equals positive 5i. So we have these 3 different answers. Now these 3 different answers came from binomials that were set equal to 0 when we did zero product property that gave us these 3 answers. So don't think about it too much. Let's just set them each equal to 0. Go plus 3, you get x plus 3. That's the binomial that was set equal to 0 that gave you the answer negative 3. And then over here, plus 5i, plus 5i. This is the binomial x plus 5i equals 0 that gave you the answer x equals negative 5i. And likewise, minus 5i, minus 5i. This is the binomial x minus 5i that gave you the answer x equals positive 5i. So what we really have is doing everything backwards. Zero product property is usually where you split them up and set them each equal to 0. We're going to do that property backwards to put them all together. You're going to have x plus 3 times x plus 5i times x minus 5i. If I set that equal to 0, that'll be the equation that gives us the above 3 answers. But again, they want the original polynomial in standard form. So all we need to do is distribute and combine like terms. Now, please begin distributing the imaginary binomials, because after all, they are conjugates of each other. What does that mean? That when you distribute, the imaginary values are going to disappear. X times x, x squared. X times negative 5i, let's just put them together. Negative 5i with an x. Positive 5i with an x, multiplied it, just put it together. Positive 5i with an x. And last but not least, positive 5i times negative 5i, it's a negative 25i squared. So notice the middle values are exact opposites, which means they cancel out. And I squared is really a -1. So I really have x squared plus 25, because -25 times -1 gives you the positive 25. So both of those blue binomials that had imaginary values that are conjugates, when you distribute them, the imaginaries disappear. You end up with the nice quadratic binomial. So we still had that x plus 3 that's in front. Bring that down. Go ahead and distribute x times x squared, x to the third, x times 25, 25x, 3 times x squared is 3x squared, 3 times 25 is 75. That's your answer, but let's put it in standard form, highest degree down to lowest. X to the third plus 3x squared plus 25x plus 75. You could have it as f of x equals, or you could even put a equals 0 at the end of it. I don't know what they do on the test or the final, but one of those will be an option. So there's your answer. If you understood that one, you're going to do the same thing over here. You're just going to have a little bit more distribution because there's actually 4 answers instead of 3. Okay? So we've done one of each. You should have enough knowledge to do all of them. If you want the video of the other ones, just watch my other videos. I have other videos that I posted already that have every single one explained. Guys, it's very important you study this, not only for tomorrow's test, but also for the final exam next week.